Here's the next question, number 24. An open loop control system results in a response of e power minus 2t into sin phi t plus cos phi t for a unit impulse input. The DC gain of the control system is dash. Okay, let's work it out step by step by first noting down the given response. The given response is e power minus 2t sin phi t plus cos phi t. We will have to find out what the gain is, the DC gain of this system. Let's call this C of t. In order to do that, we will have to start by finding the Laplace transform of this response. So Laplace transform of C of t equals Laplace transform of, now let's just open up the brackets and multiply e power minus 2t sin phi t plus e power minus 2t cos phi t. Now we will have to use two very important Laplace formulas. Now please recall, I'll write the formulas down here. The first one, Laplace of e power at sin bt is b divided by s minus a square plus b square. Similarly, we have the Laplace of e power at cos bt to give us s minus a divided by s minus a square plus b square. Important formulas, please keep in mind. Now we use these formulas and substitute them over here in this place. Let's see what we get. We now have, let's call the Laplace of C of t as g of s is equal to, now the Laplace of e power minus 2t sin phi t resembles this formula here. So that gives us 5 divided by s plus 2 whole square plus phi square. I hope this is visible. 5 by s plus 2 whole square plus phi square. Similarly, e power minus 2t cos phi t resembles this formula here. So we write this as s plus 2 divided by s plus 2 whole square plus phi square. Now here is our function. Let's solve this further. I'll write down the expression again. G of s is phi divided by s plus 2 square plus phi square plus s plus 2 divided by s plus 2 square plus phi square. Now let's solve. We get 5 divided by s plus 2 whole square plus 25 plus s plus 2 divided by s plus 2 square plus 25. This would come to s plus 7 divided by s plus 2 square plus 25. Since the denominators are same, we just add the numerators. You already know that. Okay. Now the next step is to find the DC gain. Now since we have g of s readily available, our transfer function, to find the DC gain, we need to calculate the limit while s tends to 0 of the function g of s. Very useful formula here. Please make note of this. In order to find the DC gain, all we have to do is find the limit of s tends to 0, g of s. So, the limit of s tends to 0, s plus 7 divided by s plus 2 square plus 25 will give us, we can just substitute 0 in place of s here, 7 by 4 plus 25. This becomes 0 plus 7, 7, 0 plus 2 whole square plus 25. 7 by 29 is our fraction, and if we solve it, 0.241. 0.241 is the DC gain of the control system. Well, this is the entire solution, and I hope the explanation is clear.